Hello class, welcome to the next lesson in 8th grade Eureka Math. We are still working in Module 4. We're working on Lesson 15 today. Lesson 15, the beginning of Topic C. We're halfway done with Module 4. Let's see what we're learning about lines and equations today. Today we're talking about something called the slope of a non-vertical line. The slope of a non-vertical line. So this is on pages 155 through 180, and yes, that is a lot of pages because there's a lot of graphs in today's lessons. It's not a whole lot of equations, not a whole lot of problems, but because we're doing slopes of lines, it requires us to look at graphs. And because graphs take up a little bit more space than other equations, this is going to take a few more pages than our typical lesson. So while this looks like a lot of pages, it's not really a lot of work. But let's start with the vocabulary. There are 3 vocabulary terms for this lesson that you need to know about slope. All 3 of them are connected to slope of a line. It's not surprising that one of the words is slope. So one of the words we'll be doing today is slope, where we have 3 words: declining, inclining, and slope. And as always, because this lesson is a video, and if you need extra time, if I'm going a little bit too fast, you are always allowed to pause the video, write down any notes that you need to write down, and then resume the video when you are ready. Also, if you missed anything, you can always go back and re-watch parts of the video to catch up on anything that you might have missed. Remember, you are in control of the speed that you take this lesson in. So, let's talk about the vocabulary. First word is declining. Now, declining describes a line that moves down when read or when you're going from left to right. So I did a little example right here. When we read lines, like when we read books, we start on the left side of the page and we go right. So declining means when we go left to right, it goes down. So we start on the left side and we move right and it goes down. That's declining. Declining means going down, but it's important that you know we're starting left and going right. Because if you read it going right to left, it goes the opposite. So declining means going down from left to right. Now the opposite of declining is inclining. Inclining describes lines that move up when you go from left to right. So you see inclining goes up when you start on the left. So if you start on the left and you go down, that's declining. If you start on the left and go up, that's inclining. So that's 2 different types of lines. Some lines are declining and they slide down left to right. Some lines are inclining and they climb up from left to right. Now, this is important because we are talking about the direction that lines move. In other words, we're talking about their steepness or their slant, which is slope. Slope is a number that describes the steepness or the slant of a line. So you might have gone hiking before up some hills or up some mountains. You might have climbed a wall before. You might have even just walked on a tree branch before. If you've done any of this or even walked around your neighborhood, you know that not everything is straight and flat. Some things are, some places of sidewalks, roads, mountains, cliffs, walls, whatever, ramps if you go to a skate park. Some ramps are steeper than others. Some are inclining, some are declining, some are steep, some are not steep. Slope is a number that describes how steep something is. So it describes how steep something is. Slope also tells us if it is inclining or declining. So slope gives us a lot of information. It tells us how steep something is, and it tells us inclining or declining. It tells us the slant. So we use slope to describe lines. So that's the big thing about what today's lesson is. Slope. We're going to learn to describe lines. So today, I'm going to show you how to use 2 points on a line to measure the line's steepness and find its slope. So we're going to find slope. We're going to measure steepness using 2 points on a line. So we're going to use 2 points on a line to find steepness, to find slope. That's what we're doing today. We're going to be finding and writing slope by looking at lines. So I do have a couple notes for today just about slope, how to find slope. First, a reminder, slope is a measure of steepness. And to find slope, you need to do the vertical change divided by the horizontal change. How a line changes vertically, and remember, vertically means from our other lessons, up and down. So up and down change divided by horizontal change. Remember, horizontal means left and right. So it's really up and down divided by left and right. That's how we find the slope. Up and down divided by left and right. And there's a few ways to do this. Like I said, I wrote at the bottom right here. Slope equals vertical change divided by horizontal change. Vertical change divided by horizontal change. Another way to say that is this little triangle symbol means delta. It's not a symbol, it's the Greek letter delta. It's a math symbol for change. So change in y divided by change in x. Because remember, on a coordinate grid, the y-axis is the vertical axis. The y-axis goes up and down. So vertical change is the same as y changing on a graph. When up and down change on a graph, that means the y-axis is changing. So horizontal change is the same as changing x, left and right. Because remember, the x-axis goes left and right. So x change is left and right change. So vertical change is the same as the change in y. Horizontal change means the change in x. And that little triangle just means change in x, change in y. You can also write it like this. Remember, we're talking about 2 points. So the y of the second point minus y of the first coordinate divided by the x in the second coordinate minus the x in the first coordinate. So this is another way to find slope. Changing the y divided by the changing in the x. But the simple way, and the way we're going to talk about it today, is just up divided by right. Up divided by right. And that will make a lot of sense when we start doing our examples. But today, this is what I want to kind of focus us on. Just to start with slope, this is the one that I want you to think about first, because this is the simplest way to do it. Up divided by right. Up divided by right. Up divided by right equals slope. Slope equals up divided by right. Up divided by right equals m. And m is the symbol for slope. So when we say m, we mean slope. Because it's easier to write m than to write slope. Remember, math is its own special language. So instead of saying slope, in equations we write m. So just get used to it, because you're going to see it for the rest of Module 4. M means slope. Slope means up divided by right. So this in our orange box right here, that's what we're going to focus on today. Up divided by right. So we're going to use 2 points to find slope. Use 2 points to find slope, to find steepness, and we're going to use up divided by right. So let's practice this a little bit. Those are the notes. Let's go to our first page of the lesson, page 155, and let's start practicing this a little bit. So here we go. Page 155 is the opening exercise. They gave us 2 graphs, graph A and graph B. And they're asking us, part A right here, which graph is steeper? Well, which graph is steeper means which graph changes the fastest. So in other words, to think about steepness, which one would be easiest to hike on? Which one would be easiest to hike up? So looking at this one, graph A looks like this, and so it looks like this, sorry. And graph B looks like this. Well, Graph B is steeper because it moves up faster. If you want to hike or ride a bike or skateboard or something up one of these ramps, you want to pick this one because this one is steeper. This one will be more difficult to go up. It is steeper. So graph B is steeper. You can look at it, and if you have a good understanding of what steepness is, you can just see graph B is steeper. Now, part B, what directions that explain how to move from one point on the graph to the other, right directions that explain how to move from one point on the graph to the other for both graph A and graph B. So what we are going to be doing is we're going to pick 2 points, and they already picked points for us. So on graph A, we have this point here, and on graph B, these points. On graph B, we have these points right here. Now, remember I told you slope is up divided by right. So let's do that. So let's think about that. So for graph A, we do up divided by right. So we do those. So if we start at this point, we want to go here. Start at this point and we move to this point. So we go up first, up. How many do we go up? We go up 1, 2. We go up 2 divided by how many right? 1, 2, 3. Right 3. So if we start here and we move up 2 and right 3, we get to the other point. So start at this coordinate, go up 2, right 3, and we get there. So up 2, right 3 means that the slope of graph A is 2/3. This is graph A. Graph A is 2 divided by 3 because we did up 2, right 3. For graph B, remember we want to start at this one and move to this one. So we go up and we go right because remember slope is up divided by right. So for graph B, we went up 1, 2, 3, 4 units. So we went up 4 and we went right 1, 2, 3 units. Right 3 units. And this is for graph B. So graph A slope was 2/3. Graph B slope is 4/3. So that is how we find slope. That is how we find slope for graph A and graph B. Up 2, right 3, up 4, right 3. Now, these are ratios, so we already wrote them. Let's compare the ratios. So graph A was 2/3. Graph B was 4/3. Compare them. Well, compare means greater than, equal to, or less than. So looking at this, graph B is greater than graph A. Graph B is greater than graph A. So to explain how does this relate, we say graph B has the greater slope because 4/3 is bigger than 2/3. So graph B is steeper. So in part A, we just used our eyes to find out which one is steeper, and we saw that graph B was steeper. In part B, we found the slopes, up divided by right. In part C, we saw that graph B, we compared them, and we proved with numbers that graph B is steeper. So we used our eyes, then we used math. Now you might be saying, why do we need to use the math if we can just use our eyes? Well, sometimes the change is not this obvious and you cannot really see it with your eyes. Other times, you might actually need to describe what the difference is. If you just use your eyes, you say, yeah, it's steeper, but I don't know by how much. If you look at this, you can see, well, when I find the slope, I see that graph B is actually twice as steep as graph A. Because if we do 2/3 times 2, we get 4/3. So graph B is actually 2 times steeper. So sometimes we can just use our eyes to find the answer. But if we want more details, or if we want to be able to describe it well and explain our answer, we'll need numbers. Let's try this again. Let's do another one. Page 156. Same exact thing. We have graph A, we have graph B, and we need to talk about steepness. So first of all, graph A and graph B, which one is steeper? Just looking at them, graph A looks like a harder mountain to climb. Graph B looks like an easier mountain to climb. So graph A is steeper. But what if someone asks how much steeper? What is the difference? Well, that's where the slope, we're calculating the slope comes in. And remember, slope is up divided by right. So let's look at graph A and let's look at graph B and let's do up divided by right. So starting with A, right here, we have our they gave us the 2 points for graph A. Let's go from the left one to the right one. We always start on the left side, just like reading. So we go up and we go right. And for graph B, we have they gave us the 2 points right here, and we go up and we go right. Now let's actually use those to find the slope. So we go up divided by right. So for graph A, we went up 1, 2, 3, 4. So we went up 4 divided by how many right? 1, 2, 3, 4, 5 right. Right 5. Up 4, right 5 for graph A, which turns into the fraction 4/5. Now for graph B, up how many, right how many? Well, in graph B, we went up 1. How many right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right 12. So that fraction is 1/12. So graph A was up 4, right 5. Graph B was up 1, right 12. Those are our slopes. For graph C, for part C, let's compare them. We have 4/5. We have 1/12. Which one is greater? 4/5 is greater than 1/12. So let's explain this one. Graph A has the larger slope. So graph A is steeper. And that's the explanation. And it confirms, it proves using numbers what we saw in part A. So we made a claim in part A, we proved it with parts B and C. So hopefully you get it. It's up divided by right, and we can see the difference in slope. What I'd like you to do now is I'd like you to try page 157 on your own. Try page 157 on your own. Tell me which one you think is steeper. Find the slopes and then compare the numbers. So pause the video, try page 157 on your own, and then unpause when you're ready to check with me. Okay, hopefully you took a few minutes to pause the video and try this pair of lines on page 157. Let's look at them. Remember, graph A and graph B, we're talking about slope, which is up divided by right. I'm going to add that, up divided by right today. That's how we're solving slope today. And we need 2 points. Like in our notes, we said we use today we're using 2 points. So those are the 2 points for graph A. Those are the 2 points for graph B that I colored in brown. Which graph looks steeper? Well, looking at this to me, graph A is steeper. If these were mountains, this would be a much more difficult mountain to climb. Now I need to turn these into actual slopes. Let me turn them into numbers. So I have graph A, and I'm going to use graph B. I'm going to color code. And remember, it's up divided by right. And on graph A, let's see, we go up that many, and we go right that many. For graph B, we go up there, and we go right there. So let's give numbers to those. For graph A, we went up 1, 2, 3, 4, 5, 6, 7. And we went right 1. Up 7, right 1, which turns into the fraction 7 divided by 1. So the slope of graph A is just 7. Now for graph B, we went up 1, 2, 3. So up 3. And we need to figure out how many we went right. So graph A was 7. Graph B is up 3. And right 1, 2, 3, 4, 5, 6. So up 3, right 6, which turns into the fraction 3 over 6, which simplifies to 1/2. And yes, it is best if you simplify your fractions for slope. So we find the slope of graph A is 7. The slope of graph B is 1/2. For part C, it's asking us to compare them. So we have 7. And we have 1/2, and you know that 7 is greater than 1/2. So graph A has a larger slope, so graph A is steeper. And that's the answer you should have gotten when you tried this on your own. You try this what you should have seen with your eyes that graph A is steeper, and then you proved it with numbers that graph A is steeper. Excellent work if you got it. If you did not get it right, go back and look at your work, see what you may have missed. But we do have a couple more to try. So once again, go to page 158. And on your own right now, try pair 3. Compare these 2 graphs. Compare these 2 graphs real quick. And come back in a minute and check your answers as I do them too. Okay, hopefully you took a minute to do page 158 on your own. We have graph A right here. We have graph B right here. You should have looked at these, and you thought looking at these, graph B is the steeper one. That is your answer. Graph B is steeper. But how much steeper? Let's use math to prove it. Remember, we need to go up, divided by how much right. So we're connecting our points, going up and going right. So we connect our points going up and going right, going up, going right. So let's check graph A first. Graph A, we go up divided by right. And graph A, we went up 1, and we went right 1, 2, 3, 4, 5. So for graph A, you got the slope 1 over 5. For graph B, we still go up divided by right because that is how we find slope. For graph B, we went up 1, 2, 3, 4, up 4, and right 1. for a fraction of 4 over 1. 4 divided by 1 is just 4. So those are the numbers now for the slopes of graph A and graph B. Well, let's compare now for part C. Graph A was 1/5, graph B was 4, and you know that 4 is greater than 1/5. So graph B has a larger slope. So graph B is steeper. And that is the conclusion that you should have come up with when you did this one on your own. When you did this all by yourself, you should have got the same exact answer that I just did. So if you're doing this well, that's awesome. Amazing work, everybody. Let's do one more practice before we get to today's exercises. Page 159 is another 2 graphs. Again, pause the video, take a minute to solve this, and then come back and check your work. Okay, you should have taken a minute to solve this. On your own, we have graph A, and they gave us these 2 points for graph A. And for graph B, they gave us these 2 points for graph B. And it's asking us right now, which is steeper? Which graph is steeper? Well, I'm a little bit confused by this because to me, they look the same. Just looking at them, just using my eyes right now, they look the same. Are they the same though? Are my eyes telling the truth, or are my eyes playing tricks on me? Are they the same slope? Well, let's use numbers in part B to check. So for part B, remember we need to go up and right to find the slope for graph A. And for graph B, we go up and we go right to connect the points to find the slope of graph B. That's what we're doing. We're going up and right to connect the points. So let's do graph A. Graph A, up and right. Looks like on graph A, we go up 1, 2, 3, 4. And we go right 1, 2, 3, 4, which turns into 4 divided by 4. So the slope of graph A, 4 divided by 4, is 1. Okay, so graph A has a slope of 1. Let's check with graph B. We still go, remember, slope is up divided by right. For graph B, we go up 1, 2, 3, and we go right 1, 2, 3. Up 3, right 3. 3, so that turns into the fraction 3 over 3. 3 divided by 3 is 1. Okay, so we know the slope of graph A is 1. The slope of graph B is 1. Let's compare them. 1 and 1, these are equal. So our answer, our explanation is graph A and graph B have equal slopes. So they have equal steepness. They are both equal, just like we thought in part A. The steepness looks the same. That's what our eyes told us. And then we used math to prove that the steepnesses are the same. Very important to be able to prove what you think. Too many people in this world do not prove what they think. They just think it regardless of evidence. But now we thought they looked the same, and we proved it. So hopefully you got the same results I did. Hopefully you understand what we're doing. Let's go to some exercises to practice. Let's go to some exercises right here to practice. Use your transparency to find the slope of each line if needed. We're not going to need our transparency because we're just going to be doing up divided by right. Up divided by right. So first let's find 2 points because remember we need 2 points. That's the first thing we need. We need 2 points, and we use up divided by right. So for number 1, let's find the slope. Our 2 points are P and R. You can see they put the points on there and they labeled them for us, P and R. And we're going to go up and right, going from P to R. We connect, we always start on the left and we go right. So up and right. Now right here, how many did we go up? 1, 2, 3, 4. So we went 4 up and we went 1 right. 4, and you notice how I labeled them right here. 4 up and 1 right. So we went up 4 and we went right 1, which turns into 4 divided by 1, which means the slope is 4. So m equals 4 is our answer. M equals 4 is the answer. Because we went up 4, right 1, 4 divided by 1 is 4, m equals 4, and remember m is the symbol for slope. We did that in our notes right here. M is the symbol for slope, so m equals 4. The slope is 4. Let's try number 2 exercise. Remember, you are allowed to pause the video and work faster than me and come back and check. If you know what you're doing, that is absolutely okay. Feel free to work faster than me. But if you're still having a little bit of trouble, just stay with me. That's fine. So we have P and R for number 2 again. And just like before, we're going up and we're going right. That's how we find slope. Up over right equals slope. M equals up over right. So let's go up. And how many did we go up? We went up 3 spaces. And then we go right 1 space. So we went up 3. We went right 1, which turns into 3 over 1, which it simplifies. 3 divided by 1 is just 3. So for number 2, m equals 3. The slope is 3. Because up 3, right 1, 3 divided by 1 is 3. So the slope is 3. Pretty simple so far. It is going to get a little bit more complicated, so you're fine. Just keep on pace with me. Number 3 is asking us to compare these. Which of the lines in exercise 1 and 2 is steeper? So exercise 1 versus exercise 2. So exercise 1 versus exercise 2. Well, the slope for exercise 1 is 4, and the slope for exercise 2 is 3. So we have 4 and we have 3. And you know that 4 is greater than 3. So exercise 1 is steeper. Exercise 1 has the greater slope. So their question, is there a relationship between steepness and slope? Yes. Slope and steepness are the same. Slope and steepness are the same. That's what we just learned. Because exercise 1 is steeper, exercise 1 has the greater slope, so slope and steepness are the same thing. Let's work on something a little bit different now. So far, if you look at exercise 1, we have an inclining line. Exercise 2 is an inclining. In fact, in all the practice we've done today, in all starting on page 155, everything was inclining. 155 was inclining, 156 inclining, going up, 157 going up, inclining, 158 going up, inclining, 159 going up, inclining, and the exercise we just did, 160 up, inclining. Exercise 4 on page 161 is declining. Looking at it, it is going down. If we go left to right, we're going down. So what do you think is going to happen with this? Well, let's take a look. Find our points. They gave us point P and point R. And now, just like everything else we've been doing, slope equals M equals up divided by right equals up divided by right. So this is going to be a little bit tricky, but that's okay. Watch what I do. So remember, we start reading on the left. So start with P and then go to R. There we go. Now, how far did I go up? You're going to say, Mr. Bailey, you did not go up. You went down. But slope says up. How do we do up? Did you lie to us, Mr. Bailey? You said up, but you went down. Well, this is where it gets a little bit tricky. I did go up. I just went up -1. So we have to keep going up. Do not change this to down. It is still up. It is up, but when you go down, it's negative up. Down is just negative up. So when we go down, it's negative up. So we went down, it's up and it's right, but it's up -1 because we really went down. It is up -1 because we went down. That is the trick for finding slope today. It is up a -1 because we went down. So when you go down, just change it to a negative. But how many right did we go? We still went right 1. So it's up -1 and right 1, which turns into -1 divided by 1. So the slope, -1 divided by 1 is -1. So the slope, M, equals -1, which is where you see the difference between inclining and declining lines. So inclining and declining were in our notes today, and this is the difference. So if a line is inclining, like we practiced most of today, inclining slopes are positive. Inclining means a positive slope. Declining, like in exercise 4, when you go down instead of up, declining is a negative slope because declining means going down, so it's going to be negative. This is an important fact to remember. So that's why we're writing it on the bottom of page 161. I put it in a box. I'm even going to put little stars around it because that is an important thing to remember. Negative slope is okay. Negative slope just means it's a declining line. So that's why we had all positives today until number 4, because the difference is number 4 was a declining line, so it was going to be negative. And it's negative because we go down. We go negative up. We go the opposite of up, which is negative. Might be a little bit tricky, but that's why we're here to practice. And remember, if you have any questions, if it's still tricky after that, talk to me. I'll help you out. But let's look at the next page, number 5. Number 5, what is the slope of this non-vertical line? Well, what do we know already? We know. Let's look at it. It is declining because we go left to right, it's going down. So because it's declining, I can predict it's going to be negative. I can predict that it's going to be negative because it is going down. Let's prove it, though. We have point P. We have point R. We're going to go up divided by right. Even though it's declining, we still say up. But in this time, we're going down. 1, 2, 3, 4. So we moved down 4. So down 4 means we went negative 4. Up negative 4. How many right did we go? Right 1. So up negative 4 because we went down, but we still say up because that's how slope works. Right 1. So our ratio is negative 4 over 1, which negative 4 divided by 1 is just negative 4. So M for this line is negative 4. So our prediction was correct. It is a declining line, so we have a negative slope. There we go. Another trick. Let's look at another one. So that's all about negative slopes. So inclining lines have positive. Declining lines have negative. What about number 6? A flat line. What about number 6? A flat line. We still use up divided by right. Up divided by right. Well, let's see. We have, here's P, here's R. How do we go from P to R? How many up do we go? Well, we don't go up any. We actually go up 0. We go up 0. How many right do we go? 1, 2, 3. Right 3. Up 0, right 3 turns into 0 divided by 3. Well, 0 divided by 3 is just 0. So M equals 0. That's the answer. And that makes sense because if you remember back in number 3, slope and steepness are the same. So slope is the same as steepness. This has 0 slope because this is not steep. It is flat. It is horizontal. So to summarize, so this is another important skill. Horizontal lines, you can memorize this, have 0 slope because the steepness does not change. Horizontal lines have 0 slope because the steepness does not change. That's another thing that you should know. And I'm still going to put a box around it, put stars around it, because that is another fact. So in our exercises today, we learned 3 important things. Well, we actually learned 4 things. You learned how to find slope with up divided by right. You also learned that inclining lines have a positive slope, declining lines have a negative slope, and horizontal flat lines have 0 slope because the steepness does not change. So that's what we learned today. We learned how to find slope. We learned facts about different kinds of lines. So we learned how to find slope and facts about different types of lines. Now, they do have the lesson summary for you on page 161. But you can see right here it says left to right inclining have a positive slope. Left to right declining have a negative slope. So that's 2 of the facts we learned right there. And that's 2 of the facts that we learned right there. Left to right inclining has positive slope. Declining has negative slope. And you know how to find slope. I'm going to add it to this page right here. Slope M equals up divided by right. That is the quick and easy way we learned it today. We're going to learn how to do it more mathematically in another day. But that was really quick. Up divided by right equals slope. Page 165 is the exit ticket. That's the last thing we do, so let's put that away. They do give you a homework helper with more advice to help you out with on page 167. The homework helper gives you another line to tell you if it has positive or negative. They give you the answers. Homework helper continues on page 168 where they give you another question. They tell you how to find the slope again. Page 169, number 3, another homework helper. They're showing you what they're thinking about, so you can read this to help you. And then the problem set starts on page 171. Number 1, does the graph of the line have a positive or negative slope? Tell me if the slope is going to be positive or negative just by looking at it. You don't have to tell me what the slope is, just tell me positive or negative. Same thing for number 2, positive or negative. And remember to explain why you know it is positive or negative. Explain how you know. Excuse me. Page 172, the problem set continues. And yes, it is going to be a few pages because there's lots of graphs that take up a lot of space. For number 3, find the slope. For number 4, find the slope. So number 3, they gave you P and R. For number 4, they did not give you P and R. You're going to have to find P and R by yourself for this one. But my advice for like number 4, when you have to find P and R, pick the points where it hits at an intersection. So like right here, the line hits right at an intersection in the graph. So it goes right there. And I'm probably going to, and you can also pick right here where it hits at an intersection, or you can pick right here. All of these are the points I would pick because anything else is in the middle and it's hard to measure with your eyes. So when you're finding slope, always find intersections where the line hits an intersection, not where a line is just floating in the middle like that. For number 5, and yes, the problem set continues, but we're only, I know it's 3 pages so far, but it's just because the graphs are big. Number 5, you need to find the slope again. What is the slope? And again, you have to pick P and R, but remember, you should pick where it crosses intersections. Like if it's me, I'm picking right here because it hits right at 0, 0. And the only other place where it hits, I'd pick right here to find the slope. That's what I would pick for P and R. For number 6, find the slope again. And well, this time you got lucky. They gave you P, they gave you R. It continues because the graphs take a lot of space, so we're going on lots of pages. Find the slope for number 7. Find the slope for number 8. On page 175, find the slope for number 9. Find the slope for number 10. Page 176, we're going to keep going. Lots of practice finding slope. Find the slope for number 11. Find the slope for number 12. Not done yet. Number 13, find the slope for number 13. Find the slope for number 14. And guess what? Number 14 is a flat line. So you can probably, if you were paying attention in the exercises, you know what the slope is. You don't have to do any math. You just memorize that fact. And then page 178 is a little bit of a word problem. They give you T, they give you V. It's talking about volume coming out of a faucet. It's got water coming out of a faucet. How many gallons flow out of the water in 1 minute? So use the chart to help you answer part A. And you can look at the graph and the chart to help you find the slope. So you're going to find the slope of a real world situation. So you can look at the graph to find, so use the chart to answer part A. And use the graph to answer part B. Same thing for number 16. Use the chart to answer part A. Use the chart to use the graph to do part B. Number 17, same thing. You're doing slope in real world problems. But remember that, and that's the problem set. Page 180 is the end of the problem set, number 17. I know it was a lot of questions. I know it was a lot of graphing, but it is good practice finding slope. Also remember that all of my answers to the problem set are on the Google Classroom, so you can go back, check your answers with mine, see how I did it so that you know the right way, you get the right answers, and you can check yourself. Great things to do to check your own work, check your own answers. Use my answers on Google Classroom to help you. When you feel confident that you know how to find slope, and when you understand slope well, using the up divided by right method, then you can try the exit ticket on back on 165. There are 2 questions on the exit ticket. Number 1, you find the slope. Number 2, you find the slope, and that's it. Now, my answers to the exit ticket are not online, but you can still ask me for help. When you're done with the exit ticket, take a picture of it, turn it into the Google Classroom so that I can see you know how to find slope. Remember, the big goal of today is learning how to find slope. If you can find slope using the up divided by right method, you're great today. Just prove it with the exit ticket. Check your answers to the problem set with my work. And remember, as always, ask me for help if you need help with any of this. I'm ready, able, willing, and I'm here to help you. You just have to ask. But work hard, have fun with it, ask me for help if you need it. But otherwise, have a great time. I'll see you next lesson.